Hello everyone, my name is Dr. Wei Kiong Tan, CTO of T-Smart Private Limited. It's a shame that we're going to meet during the Photonics Plus on 7th Feb, but hopefully the message that we want to share with you guys can still get shared through this presentation. Now, I'll be talking about the Thermopile 2.0 from T-Smart Private Limited. Okay. Just as a quick company introduction, T-Smart Private Limited is a Singapore incorporated manufacturing company. We've been around since 2019. What we provide is novel and superior manufacturing technology to traditional infrared temperature sensing architecture. Now, what we do is really to fulfill the need for predictive detection, solutions, and analytics. So we hope that the users of our products, can be inspired to develop new applications and new ideas that they have not been able to realize before. Now, we want our customers to be more thermally aware. Now, what that means is really to have in charge of predictability, detection, analytics, and specific intelligence. So we like to challenge conventional approaches in doing things, using enabling technologies to keep us safe. And ultimately, for T-Smart, we provide these predictive detections and analytic solutions. Now, our expertise can be broadly divided into two categories. The first is in the area of thermal sensing. So here we are really talking about the next generation Thermopile sensor solutions. So what we have is offering all the benefits of the Thermopiles, for example, the high linearity and so on, but with significant improvement in the sensing performance. I'll talk more about this Thermopile 2.0 sensor later on. The other part of our strength within thermal sensing is in the application design, whereby we try to understand the needs of an application and offer optimized application boards to enable quick solutioning or prototyping. Now, our whole thermal sensing solution is also built upon our new anatomy of packaging, what we call the LAAP, or large array area packaging format. Right? So we believe that the future of MEMS is really in packaging, and that's why we're coming up with new ways to package the Thermopile sensors. The other area of our expertise really lies in enterprise solutions. Now, we are an enterprise solution company, and what that means is really that we offer both the hardware and software solutions to aid customers to speed up their product development cycles. Now, we base our software solution on this T-Measure platform, whereby it is a platform that offers multi-sensory, that allows for multi-sensory inputs. It's powered by AI engine within the sensor core itself, and we're able to offer this deep insights of the data collected. So go beyond just pure raw data and offer deep insights for the applications of interest. All these are made possible through our T-Smart middleware, which allows for operation at the edge, and thereby easing the hardware infrastructure requirements. Now, going on into our product, which is the Thermopile 2.0. Now, we call it the Thermopile 2.0 because we believe that it offers a very marked improvement over the market available Thermopiles. Now, just a quick background introduction for those who are not too familiar on IR thermal sensors. So the IR thermal sensors basically absorb IR radiation and converts this thermal energy into some form of output through a temperature sensitive element. So the commonly seen temperature sensitive elements would be like bolometers, which basically have a resistant change that is proportionate to the temperature that's being absorbed, I mean the temperature change. The piezoelectric sensors, again, whereby the temperature change is measured through the charge accumulation. And then we have the thermoelectric sensors like the thermocouples or thermopiles, which are essentially a series of thermocouples, whereby the temperature change will induce a proportionate change in the sensor potential or the output voltage. Now, the key advantages of thermopiles over the other thermosensitive elements are really in its highly linear response, right? What that allows for is definitely a easier calibration process. This absence of frequency noise or 1/f noise, this is important, especially in applications requiring imaging, as this 1/f noise will add to this pattern noise that we typically see in the IR images. And the thermopiles, they are more tolerant to ambient temperature changes. We like to think of it, they're more thermally stable. Now, of course, it's not all good for in the camp of thermopile. The thermopiles available in the market today are typically plagued with very low sensitivity numbers. The responsivity numbers of thermopiles in the market today typically run at about less than 100 volts per watt. Now, for T-Smart's Thermopile 2.0, it is our answer to the main disadvantage of the current generation of thermopiles. Now, the responsivity of Thermopile 2.0 is easily in excess of 25 kilovolts per watt. Of course, that's measured at DC. Now, that represents a 2 orders of magnitude of responsivity that's higher than the current generation of thermopiles. So the table below really just gives a very quick overview between the typical thermopile and Thermopile 2.0. Now, one thing, because of the high responsivity of Thermopile 2.0, we're able to reduce the active area down to very small sizes while still maintaining very high signal-to-noise ratio. Now, as you can see below, the signal-noise ratio for Thermopile 2.0 can be up to like 15,000 root hertz. Responsivity at die level will be greater than 30,000 volts per watt. And the noise equivalent power, again, we're looking at about 2 orders of magnitude better than the current generation of thermopile. And of course, with all this, that means that we do have a higher D star, which effectively is a figure of merit that compares across these thermal detectors. Some of the features and benefits of Thermopile 2.0. We're looking at the single element, in this case, in a package format, because we are introducing our Thermopile 2.0 single element in our TQ package, which is this new anatomy of the packaging. It comes in a very slim profile package, so it can fit into slimline products for customers. The IO pins will be TLCAN compatible, so it's an easy drop-in upgrade for existing products. Because the package will come automatically sealed, it enables applications in very harsh environments. The dielectric construction of our packaging eliminates any need for secondary housing while maintaining very good thermal stability. So the high responsivity, of course, we've talked about that, and this provides for high sensitivity for applications that really require measurements of very weak thermal signals in the presence of noise. Of course, this is also aided with the fact that we have very low noise equivalent power. Now, the Thermopile 2.0 that we're introducing can come with an integrated lens option. That means that we can have a very tight field of view on a die level format. Because it has very small active area, so it allows for easy drop-in replacement to existing products with optical lens, and this will allow for a very tight field of view. So this allows for very long distance measurement, right, or maintaining the same spot size. Finally, of course, the signal to noise ratio, very high signal to noise ratio, which offers greater repeatability of measurements. One thing to note that we highlighted earlier, which is on the field of view enhancement, or another way to look at it is the distance to spot size enhancement. As some of you might be aware of, that the field of view is there's a direct correlation to the detector element size, and of course the smaller the detector size, the smaller the field of view that one can achieve for a fixed focal length. So if we were to drop in Thermopile 2.0 into existing optics, for example, the existing optics with a 500 by 500 micron die gives you an original distance to spot size ratio of 5:1. If you were to drop in one or more parts, let's say with a 40 by 40 micron part, you will see an improvement to 63:1 distance to spot size ratio. Of course, as the table shows, you can get very significant improvement, even up to 1800:1 if your starting is 60:1 at a 1200 by 1200 micron sensor active area size. So our whole value add to this with our Thermopile 2.0 is really the ability to offer very narrow field view applications without redesigning the whole optical system, right? So it offers a very simple drop-in replacement upgrade path to enhance this distance to spot size ratio. The Thermopile 2.0 has the highest thermopile sensitivity that's available in the market today. So which means that you can really use it for applications that might not be suitable for thermopiles before, for example, for gas leak detection or even for spectrum analysis. It allows for the smallest footprint in a thermopile sensor. Therefore, it's well suited for applications that require very small footprint where real estate is a concern. Things like wearables or ultra portable applications. Right. Unfortunately, there will not be any Q&A. But if there were to be any questions with regards to this presentation, or if you have any applications that you think a thermal solution will be helpful, and just like to explore and find out more of how T-Smart might be able to partner you and help you with your solutions, please do contact us at inquiry@tsmartsystems.com. Thank you very much.